Hello friends, welcome to my channel. Let's have a look at problem 141, linked list cycle. This video actually is a warm-up for today's daily challenge problem, that is problem 142. So for this problem, we're going to share a treatment based on slow fast pointer. First, I'll read through the problem statement to digest the requirements. And then we explain the intuition and the idea. And finally, we do the coding. First, let's look at the problem statement. So given the height of a linked list, so we want to determine if the linked list has a cycle in it. So this is the main problem requirement. So we are required to return true if there is a cycle, otherwise return false. So here are several examples. In example 3, so the return is false, which is very easy to understand. And in example 1 and example 2, the returns are true. Let's take a look at example 1. So here, so if we look at the height is 3, so we move forward to 2, to 0, to negative 4, then we moved to 2, and then to 0. So this is a cycle, right? So we are going to return true. So before we do the analysis, it's also good to have a look at the constraints. First, the number of nodes in the list is in the range given by the closed interval 0 and 10 to the power 4. So this basically determines the problem size. Secondly, the node values are in between negative 10 to the power 5 and positive 10 to the power 5. So that's not very essential for this constraint. So position is -1 or valid index in linked list. So, the position is not an argument passed to the function. This is just the internal thing for this problem. So with that said, we are ready to look at the analysis. First, the treatment is a slow faster pointer method. So this method actually is very intuitive. So the thing is that if the linked list does not contain any cycle, right? Then if we have a slow pointer and a faster pointer, then the slow pointer can never catch up the faster pointer, right? Then if there were a cycle in the singly linked list, then the fast pointer, the faster pointer would catch the slow pointer again at some place in the cycle. So this is the intuition. So for this problem, actually, it's just to detect the existence of a cycle. So actually, a question can be asked is the following. So can we return the entry point of the cycle? For example, in example 1, so this is node 2. And in example 2, so the height is also the entry point of the cycle because it itself forms a whole cycle. So with some additional reasoning, so this is readily achieved. So please see next video for today's daily challenge problem. So we are going to explain the details. So for now, let's look at the solution here. So for this solution, actually, the most direct way is to use a set to monitor, right? Then you iterate. So once you find a node that has appeared before, then you see a cycle. So now let's first directly write a solution using the slow fast pointer, and then we also quickly write a brute force solution. So this solution is based on slow fast pointer. So first, I'm going to treat a case. So if not height, so it's an empty one. So we're going to return false. There's nothing. So they are going to return false because there's no cycle. And then what we're going to do is to use current equals pre equals height. So then we're going to use pre and current as slow and fast pointers. So basically, let's check. So if current and current next, notice that current is the faster one. So then we're going to set the slow pointer to be pre next, and fast pointer to be current next at next, because current next is not now, so it's good to call next again, right? Then the thing is that if pre equals current, it means that these two guys can meet again. It means that there's a cycle in the linked list. So we're going to return true. So otherwise, so after we finish this while loop, then the first pointer arrives at now, and then still cannot meet together. So it means that there's no cycle. So we're going to return false. So this snippet of code forms a solution format. So before we make any comments, let's first do a test. Yeah, it passes the first one. So now let's look at generic case. Yeah, it passes all the cases. So here, if you look at this while loop, so if not hide, if hide is now, right? So this we didn't enter this while loop, then we directly return false. Therefore, this if part can be commented out. So we can directly from here. Now let's check. Yeah, it passes all the cases. So let's see. Yeah. So this is a solution we want to present. So as we mentioned, so we can use a brute force solution to do this. Let's do it quickly, just to make it as a remark. So here, let's use this one as V1, and this one, so I'm going to call it brute force. So with a set abstracted type, so this is more brute force, I would say. So here this is very simple. So we can still use a set called scene, and then what we are going to do is let's set the current to be hide, and then we're going to iterate, right? So while current, and then we're going to check if current in scene, and then we're going to return true, because this means that we have a meta cycle. Otherwise, so we're going to add the current to the set. So afterwards, if nothing has returned, so we're going to return false. Either way, we're going to traverse the linked list. But here, the problem is that, so we're going to store the nodes. So this actually, for each node, if they have the next, we need to store the next recursively. So this actually uses a lot of space. But for now, let's test if it can pass the submission. Let's submit. So here, let's see, input -1. So this this output should be true, but let's see, if current extend, so we're going to return true, and then otherwise, so then right. Oh, so here I guess the one thing, current equals current next, right? So we need to traverse this linked list. Now let's submit again. Yeah, it still passes. And still, the problem here is that we use a lot of space. So here, space complexity is a thing, right? In other words, we use a lot of space to store the pointers. So with that said, I guess that's about it for this specific problem. So this problem is an easy one. However, if we look at this method, so this method actually is not trivial, because it's actually related to the faster slow pointer method in a general context like graph, right? Detect if there's a cycle in a graph. So with that said, I guess we are ready to look at this daily challenge problem. So you're welcome to check out next video. With that said, I guess that's it for this video. Thank you.